In this video, we're going to take a look at what the chain rule says, which allows us to take the derivative of the composition of two functions if we know the derivative of those two functions. And then we'll see a couple examples of how to solve it. So here's the rule that if f and g are functions, and so if g is differentiable at x and f is differentiable at the output of g, then the derivative of the composite function at x is given by this function. All right, so that might look like a whole bunch of symbols just crammed together, and it kind of is, but I will show you how to apply it and what it means in the real world. And then they've got this in dy dx form. So if y is a function of u and u is a function of x, then you can write it like this. I'm going to explain this in a separate video because this is a separate way to think about the chain rule, and some people find it a lot easier to think about than the chain rule kind of in this function. But let's give this a shot, kind of the way it is. So let's think about this one for first. So we've got our inside function was the natural logarithm of x, and our outside function was cosine of x. The first thing we need to do is we need to take the derivative of both of these elementary functions, and this is in our reference sheet. I've said before that the Calculus AP exam does not have a reference sheet. So these are things that you are going to kind of need to memorize. And you'll see the functions that come up over and over and over again. And those are the ones that you really need to work on. Sine, cosine, e to the x, and the natural logarithm of x are kind of your go-to ones. So the derivative of cosine is negative sine. The derivative of natural log is 1 over x. So what we do here is the derivative of y with respect to x is equal to the derivative of f, which is negative sine of x, but instead of x, we're going to use g of x. We're going to use our inside function. So that means negative sine of the natural logarithm of x. So this is complicated notation, this part, but look at what I just did. I took the derivative of the outside part and left the inside part the way it is. Okay, and then we've got to do the second part, which is multiplying this by the derivative of g. And the derivative of g is 1 over x. Okay, so we can write that a little bit more simply as negative sine of the natural logarithm of x over x. So that is what the derivative of this function would be. So we've got two terms. The first term is the derivative of the outside function applied to the inside function just the way it is, and then you multiply that by the derivative of the inside function. Okay, let's turn over to this example now. So here, our inside function was 3x plus 1. We just used the power rule on that. And so the derivative of that is 3. We haven't really talked about finding the derivative of the square root of x before, but it's not that hard. So we just use our exponent rules a little bit. The square root of x means x to the 1/2 power. And now that it's written like that, we can see that we can just use the power rule on it. So we're going to use the power rule just the same as we do when the exponent is a positive integer or a negative integer or a fraction. It all is the same rule. So the rule is we're going to take the exponent and we're going to multiply it by the coefficient. So we move the 1/2 down here, and then we take x and then we reduce the exponent by 1. So what's 1/2 minus 1? 1/2 minus 1 is negative 1/2. Okay? And if you want to make this look a little bit cleaner, you don't have to. You can certainly leave it like this, but Since that's a negative exponent, we can make it a positive exponent and move it into the denominator. And another thing we could do is we could take x to the 1/2 and turn it back into the square root of x. All right, so if this were a multiple choice question, you might have to look for an answer like this when they ask what's the derivative of the square root of x. But if it's a short answer response, you could leave it like that if you wanted to. All right, so once again, let's think about what the derivative of this composed function is, this function that chains these two functions together. So the derivative of y is dy dx. The derivative of y with respect to x, it equals the derivative of the outside function, which is 1/2 times the square root of, but instead of saying x, we're going to replace that with our inside function. And then the last thing we do is we multiply that term by the derivative of the inside function. The derivative of 3x plus 1 was 3. So we could either put the 3 out here, or we could just kind of turn our numerator into 3. Okay, does that make sense? So it's a little bit of a trickiness recognizing your inside and outside functions. But when you do that, the chain rule says that you take the derivative of the outside function, but instead of using x as your argument, you use the inside function as your argument. And then you multiply that term by the derivative of the inside function. If you do those things, that gives you the derivative of the chained function. All right, in the next video, I'll show you another way to do that, thinking about this other way of thinking about it, thinking about the outside function as being a product or a function of u.